Looking back at this article on 2 minute linked lists, having gone through it, something that stuck out to me was the OK stack, an OK stack essentially, which implements peak into iter mut, and the final code looks like this. So I basically just grabbed this code, which is straightforward to read, um, and created a module with it. But I needed to make a few changes. So, for example, if I pull up the code in this one, let me see. In the iter struct, if you go back here, the iter struct, it only has a record field for next. But what I want to do is to figure out if the item that is under iter essentially has a tail. So to do this, I've introduced a method, a function to return a boolean based on this record field called hasTail. And the way it's modified, if we go into iter, which is like that, and then if we were to modify it, what we're doing is I'm checking that, well, assuming it's a head, but it'll, even if it'll update later, but still, assume it's head. We check that the next node that is pointing to has something, so it's not a null value. And then we, since this acts as a guard, we can straight away unwrap into the next one, so basically head plus one. And then we check if that is a none, so it has a tail at that point. And this is used when I'm drawing the world essentially, to change the color of the cell that holds the head. So if you go to cell, it's a very simple struct, and if you come back here, the update part is the interesting bit. So this is using Piston 2D, and when the update takes place, the Piston has got an event loop. Input is handled. When the input handling takes place, it just basically changes the direction on the mutable instance of the player, which is the snake. And this essentially it creates a new list. And the trick I'm using here is I'm basically taking the tail, removing. So here we create a slice. Here we create a slice. So from the slice, I'm slicing and I reverse the list. I'll explain why. Because the way this list works, so let me go back. It's head first, so let me go back up. So when we push onto the list, the cell that's inside the node, in parlance here it's a node, right? T is the cell, by the way, right? So the node that's pushed on is always the head. So the last node pushed onto the list is the head. So that's why, so here when we iterate and collect into a vector, this is head first. But we want to work through tail first, so we reverse it. And I'm basically skipping the first element of the reversed list. So that way I'm dropping the tail, and then I push the new head onto it, and yeah, that's done here. So let me come back, and then the list is replaced. Now what I want to do is I want to show this running. I think that's, I don't clean up all the warnings and stuff, but here we go. It just ran. Let me just get the snake to play around a bit. Does it come back? Yeah. So right now it's just a free run type thing in the sense I can go down and I can go back on itself. I can go down again. So I'm basically looping over his body. So that's obvious because I haven't got any turn protection essentially. Um, I'm not guarding against that. Neither am I checking for collisions with the wall. So the green border is the wall, but later I could just remove the green border and just have it as free flowing. And yeah, so right now I can just turn around, wiggle, do all the stuff. I can go over itself vertically, I can go left and right, back over itself as well, which is interesting. Now, let's forget the snake, and I want to focus more on this side. By adding debug annotation, what's nice is we get to see our list, and we can see the list has a head, and some means that each one of these are optional. And so the options, as we can see, there's some because they're holding something, whereas the final one has a none, because that's the end. And we can see the head is handled here. You can just, it's showing the head as well. Let me let me see if I can bring the snake back. Is it coming back? Y is reducing. Yeah, it's gone a long way. It's basically, it's gone vertically up the screen quite a bit. So let's make a turn left and a turn down. Okay, now we're on like 5. So we should be coming this way. So while I talk, it'll just like do a run pass vertically down. It's coming on the it's heading on the 5th cell, and the offset is working its way from negative towards positive, so it's coming down. Let's see, here we go. Oh, there we go. It's back on track. And so what's happening is I don't have to copy. So one naive approach is to think that, okay, we have the snake with the head, and a move of the head is basically you take the head's position and copy it to the next cell, and then the next cell copies it to the next cell, etc., etc. But I was reading online and I found an article that was saying, hey, the solution is really subtle and sweet. Is you basically remove the tail and you just replace the new head. With visually, it looks like it's turning, but all that's happening is you just change the cell. Now let me kill this, and now of course here we are causing an extra allocation here. That's not great. So this demo in itself is naive to a point as well. But I just want to have a play with the linked list and just show you this live demo. Let's just run it one more time because it's so cool. Yeah, once I just like got it working in like a this was a clean room run. I didn't look at anything else. My first challenge was to draw the world in a better way. So the world stuff I pulled from an example, but then I want to tweak it to get this little grid spacing in between. So the way that works is I have like a compensation factor, and then when I'm drawing the world I use like an offset, and I'm compensating for everything by the offset. Yeah, the next step is for me to just dive into this and see if there is a better way of doing this without using a linked list, and I'm keen to play around with a memory map, and like use some unsafe tricks, and maybe malloc, and do something like totally unsafe, play around with libc, and see how we can just take a pointer based approach, and then every time we add a cell, we just basically allocate it um, by pointer, um, and handle it that way rather than sticking to a list itself. Um, but yeah.